free and gives you a good result. Good results with some kind of dependence. We'll discuss what these mean later, but these are the three possibilities. COMSOL and the CFD module in COMSOL can negotiate a large number of physical flows. These includes all of these: steady, unsteady, supersonic, Newtonian, non-Newtonian, and so on. You can incorporate other equations or approximations as well, like in natural convection. You have the Bose-esque approximation, where you say, I don't want to model the gravity term except in the y direction, where I have natural convection. So the buoyancy effect is only limited to the y momentum, normal to the gravity direction. You can solve the Navier-Stokes equation on general fluid mechanics on more than one set of grids or domains, where an element can have 0.7% water, 0.3% ice. So multi-phase, you have a phase and a phase at the same time. We'll look at them later. You can have helical flows, which are, or module, which are suitable for lubrication when you're modeling lubrication problems, or shallow water open channel equations, where you have water meeting air, so you have a free surface, there's zero shear in this direction, and you have to track this free surface, and you would have waves. So this interface becomes another problem. Like we said, Darcy's law and Brinkman equations, which are used to model flows in porous media, and so on. If you have really small flow scale, then you might consider other modules than the Navier-Stokes equations. Navier-Stokes equation assumes the continuum assumption, that the fluid that we're talking about is a continuous thing. Okay? It's like a gel. It's not a series of particles. While I can, at higher altitude, for example, flow around a wing section of a jetliner cruising at 40,000 feet. This is not the case. The air density is so low that you don't meet air as a continuum. You might, but you have to calculate, you have to be sure. The air molecules do not fill the whole problem domain. In that case, these Navier-Stokes equations stop being relevant. So you calculate what's known as the Knudsen number, which is the ratio of the mean free path, which is the length of the section that a fluid particle travels before hitting another particle, divided by the characteristic length of the experiment, like a section, an airfoil, an experiment, with channel of the width, and you see if this is close to 1 or larger, then Navier-Stokes are not applicable. Let's say this is 1. So the mean free path is 5 millimeter, and this is 5 millimeter channel. So 5 millimeter. So a molecule, an air molecule, whatever that is, travels for 5 millimeters before it hits another air molecule. Okay, this is what the free mean path means. But then the height of the channel is 5 millimeter. So it could go the whole channel without hitting another molecule. So in this case, the continuum assumption breaks down. More like a like a multi-body dynamics type of problem. So the Navier-Stokes equation, which are based on the continuum assumption, do not hold anymore. Okay, it's fine. Any slip flow regime, but they're not applicable. The CFD module has a vast range of tools for evaluating quantitative results. So qualitative studies typically form the basis of understanding, which in turn can spark new ideas. So you might try a toy problem to see how the fluid reacts to some actual boundary condition, not with the aim to reproduce your physical problem, but with experimenting. This is qualitative studies. Quantitative studies form the basis for optimization and control. And I want to simulate the flow to perfect, to optimize the shape of this obstacle, so I need an actual true to scale module, okay, or model. So these can greatly improve products and processes, but usually do so through a series of many smaller steps. The module includes a large number of fluid flow interfaces for different types of flow. It also includes chemical species transport. Think about anything, you can include anything. Think of anything that you can include with the fluid flow, and chances are you will see it available to you in COMSOL. Reacting flow, species transport, two-phase flow, three-phase flow, multi-phase flow, combustion, solidification, melting, vaporization, and so on. Okay, so really a huge number of modules. So these are some of the things available to you. Look at these at your convenience. These are some of the classifications: laminar flow, turbulent flow, creeping flow, based on Reynolds number, and then you have the multi-phase flow. I'm trying to group these things together, okay? And then you have the multi-phase flow, include the bubbly flow, mixture model, Euler model, the two-phase level set, and two-phase phase field. We'll look at these when we do porous media or multi-phase flow. The laminar three-phase flow and phase field flow. في non-isothermal flow, which we experimented with لما يكون we need to solve the energy equation. So laminar or turbulent and conjugate heat transfer, conduction, and then وراها convection, same thing. We have porous media ثلاث أربع أشياء, Brinkman and Darcy. في reacting flow, so you solve, in addition to the flow, the equation of fluid mechanics, you solve a chemical reaction equation, and you take its output in terms of heat, in terms of mass being pushed here and there because of the expansion. So it's like a source. Turbulent flow with reacting flow. Reacting flow in porous media, أيضا rotating machinery, thin film flow, high Mach number, laminar or high Mach number, turbulent, and these are some of the snapshots of these modules in the CFD module. Okay. Let's look at a problem. Let's look first at 2D flow over a back step. بعدين we'll look at transient non-isothermal flow over heated electronic chips, and if we have time we'll do solidification multi-phase. Any questions? So number 2 or 3 كم قلنا 2 of the things you have to turn in next Tuesday. We're going to do the first class problem, which is basically this. Okay, so you have individual instructions or individual steps. You just basically apply them, and then another problem where you do the lid driven cavity problem. You have a cavity with fluid inside, and there is no pressure, well, a gradient in gravity, there is shear إلى الأبد. Okay. Okay, so go ahead and start console. تبي تبدي مكان جديد؟ تبي تبدي فايل جديد ولا عادي؟
شنو؟
تبي تبدي فايل جديد؟
كان هو صور
مو قلت بتسوون اثنين؟